Hello, my name is Joel Titus, and I'll be taking you through my project Quality Assurance Support System. So our PowerPoint overview, we're going to cover the project description, the project functionality, project organization, flowchart, error checking. To get into our project description, let's first understand what the problem statement is. And that is that a company, the Cardinal Seed Company, is experiencing a high rate of returns on their seed kits. So the company would like an application to help them fix their problem. The application needs to be used by various entities to include customer service representatives, quality assurance representatives, and the management. So the project functionality. The user will be able to make new data inputs using a form that standardizes the data being put into the tables. The user can also make changes to data that's in the tables using an edit function. And they'll be able to either make changes to existing data or delete entire rows. The user can also view data in its raw form and apply various sort and filters to extract the data they need. And the project will have a dashboard, and that dashboard will create graphs and will give a very good visual representation of top return reasons and proto charts. Okay, here's the application homepage. And to begin, click Start. We have an explanation of what our buttons do. And you can view data, can sort the data, primary, secondary, tertiary reasons of return. You can sort by procurement method. You could reset it and sort by the date. Another button is the dashboard. So this dashboard takes us to reasons we selected, reasons selected as primary, secondary, tertiary. There's a proto chart, some other displays. If we want to add new data, we could type in June Marie 1, and we'll assign some codes, and the code explanation is up here in the notes, to which each code corresponds to which return reason. And if you hit OK, it's going to ask to check customer ID, transaction ID button. So once we hit that button, now we'll proceed. And if we want to look at the data real quick, June Marie 1, etc. is logged. And say we want to change that June Marie to a 2, and we'll change this to a 14. Then in the application, we can hit Edit Data, and we want to edit June Marie. That's a 1. And we're going to edit the data. We can change that to a 2. And this to a 14. And we're going to check it. And OK. And when we view data again, June Marie is now 2 and 14. Thank you. Project organization. The project design time, I built dashboards, graphs, and tables, forms, and I chose which spreadsheets would be hidden from view depending on the user selections. The project runtime is where the user can enter data, they can edit data, they can apply filters to the data set, and they can choose what graphs they want to see on the dashboard. All of the data in the project was created during runtime. Concurrently, during testing of forms, charts, and testing the application's ability to update the charts quickly, data was created. Outputs for the project would be the Pareto chart, the top 5 primary, secondary, tertiary reasons of return, and the tables associated with the data. There are 4 spreadsheets that the user sees while they're using the application: the start, the dashboard, the data, and the Pareto charts. Data spreadsheet, which is your main spreadsheet, is kind of what the project's built around. So subs take data from a form and they make new entries to the spreadsheet. Subs can edit data, they can also delete data, or you can just view the data that's in that spreadsheet. So the data spreadsheet elements of it, such as the count, are transferred to the Pareto spreadsheet, where the user can also view the Pareto spreadsheet, and Paretos were used as the source for pivot tables and pivot charts. In the pivot tables, pivot spreadsheets, those were hidden from the view of the user, but the resultant chart was added to the dashboard, and buttons were built to control that view. So in the code and subroutine organization, there were 4 forms. Each form helped provide a user interface to get input data. And then the subroutines were broken into a main sub, a functionality sub, or a sub that would change the user view. And there were 4 subs that were called upon by other subs. Our main subroutine flowchart. So when the user selects the start button, the subroutine is started. The first step is to make sure that the application is ready, and when Excel workbook is ready, it'll move on. Then we refresh the workbook, the variable is initialized, and an opening form is displayed to the user. Now the user will select what they want to do, and the resultant subroutine will be called. As the main sub makes a call, it'll go into a functionality sub, whether that be new data, edit data, etc. And after that functionality sub is completed, the main sub will update the Pareto table with any changes that may have occurred. Then the main sub ends, and the user is brought back to the starting screen. Error checking in the project took on multiple forms. The creation of a check customer ID transaction ID button was very preventative in nature. So when the user checked that button would be looking for blanks, and if there was a blank or if there was an incompatible data type, such as if it needed to be an integer for the serial number and there was no integer there, it would display a message box telling the user they had to fix their issue. That same button also would look for matches. If the customer ID and the serial number existed in the database, it would report back to the form. In the case of new data entry, a match is bad because that's a duplicate. And the OK button was looking for a Boolean from the check ID button, and so that no duplicates would be made, that check ID button had to return the correct Boolean logic. In the case of edit or delete data, you want to find a match before proceeding, and again, the edit data button required a Boolean logic to move forward. Another way that errors were prevented was the forms had combo boxes, and those combo boxes, this prevented user data entry errors. And if there was a blank combo box when the user hit OK, the message box would pop up informing the user there was a blank and it needed to be corrected to proceed. There was also error handlers embedded in the functionality of the code. So the delete row subroutine, the edit data subroutines, the main subroutine, if they encountered an error, would be directed to an error handler, which would help the user. If you have any questions, I can be reached at my Louisville email address. Thank you for your time. Bye.